Hello guys, in this lecture we are going to talk about associate containers. So yeah, so associate containers, uh, the examples of associate containers and how we are going to use those containers. Okay, so the examples of associate containers are sets, then we have maps, okay, then we have multiset, and then we have multimap. Okay, multimap. But for this lecture, the scope of this lecture, we're going to talk about only the sets and maps. Okay, if you are interested in learning about multi-sets, you can use documentations for that, and multi-map also you can use the documentation. The only difference between the set and the multi-set is that a set is used to store unique values, okay, unique values, whereas a multiset can have same values twice or thrice, stored twice or thrice. Okay, same way in the case of maps, it is used to store unique IDs, uh, okay, may have duplicates as well. Okay, but duplicate is not possible. If we try to duplicate, the value changes, okay, if the value is different. Okay, because id will remain same, right? It is used to store unique IDs, whereas in this case you can map multiple values. Okay, now let's talk about sets and maps. Okay, let's move to the next page. So first thing that we're going to talk about is sets. Okay, a set is a data structure, okay, which is used. It is a data structure, okay, it is a part of container when you talk about STL. So it is used to store unique values, okay, values. Let's say we have a set. Okay, so what is the syntax of set? Okay, first we need to know how we initialize set. Okay, so we write set, okay, then we give it a data type. Let's say we want integer type of set, okay, to store the integer values. So we give integer as the data type, and then we give the name could be anything. I'm giving s here, okay, and then semicolon. Now if we try to push elements into stack, so to push the elements we use insert function. Insert, okay, then the element that we want to insert. Okay, okay, yeah. So if we insert element, let's say I inserted 5 already. Okay, now let's say if I try to insert 5 again, so the set will have only one 5. Okay, so there is only one 5 stored in the set. Okay, so now let's say I try to insert 1. Okay, so the set has 5 1 as the values. Okay, now let's say I inserted -1, so the set will have values -1 1 and 5. Okay, and set the values, okay, I was wrong here. So the values that are stored in the ascending order. Okay, 1 comma 5. Okay, then -1 1 comma 5. Okay, and finally let's say I again try to push 1 here, so the set remains this way only, it won't change. Okay, there won't be one won't occur one more time in the set. Okay, now yeah, these are the elements. This is how set stores the element. Okay, now let's go to the next page. Okay, now we already know that the set stores the element in the ascending order. Okay, these are the points. Okay, ascending order in which the set stores the element, and it stores unique elements. Okay, now let's say we want to delete any element. Okay, so what we'll do, we'll create an iterator. Okay, set int, because this is an integer type of set, right? This was okay, then we give 2 colons, and then we write iterator. Okay, and then we give the name of the iterator. So let's say I name it it. Okay, equals to, let's say I give it, let's say I want to erase the first element. Okay, or delete the first element. I give it s dot begin as the iterator. Okay, as the value. So what happens is, let's say this was our set. Okay, now it points to this element. Now if I use erase function, so s dot erase it, if I erase it, so as it points to this element, this element gets removed. so we get new set as 1 comma 5. Okay, and now we can also increment it. So let's say I increment it. Okay, it, this is it, and then plus plus. Okay, now let's say if I do it plus plus, now it will point here. Okay, yeah, so now it is going to point at this element. Okay, so if I try to erase it now, erase it, let's say this was also an element right now. Okay, this isn't erased, so it plus plus will point to this element, and if I try to erase it, this element gets removed, so we are left with minus 1 comma 5. Okay, okay, now let's get back to the Visual Studio Code and let's see how it works. So let's create the set. Okay, set.cpp. Okay, now let's write the boilerplate code. Okay, uh, yeah, yeah, so let to work with set we have to include its library. Okay, so we write has include set. Okay, yeah, so now we can work with set. Let's say we create a set of type int. Okay, s is equals to, let's say I give it a value 1 comma minus 1 comma 5. Okay, uh, I can give it a value like this as well, but since I want to push values as dot insert, I want to show you how to use insert function. Let's say I insert minus 5 first. Okay, then let's say I insert 1, then let's say I insert 22. Okay, so what will be the order if I print the elements in the set? So it will be minus 5, 1 and 22. Let's try to print. Okay, for while not s dot empty, same way in the case of stack, right? As in the case of stack, cout uh, s dot top. Can we use s dot top here? No. So s dot to insert the first element. Okay, we don't use actually the while loop. Okay, so what we use, we create an iterator to the first element first. Okay, set int iterator. Okay, forgot to put semicolon here, put colons here. Okay, so iterator. Okay, iterator it equals to s dot begin. Okay, okay, for auto it belongs to for auto it equals to, let's say I give it a name itr. Okay, so for it belongs to equals to itr. Okay, it does not equals to s dot end. Okay, as was the set, right? it plus plus. Okay, each time I increment the iterator by 1. Now cout it star, since iterator points to the element, so star it will dereference it. Okay, and will get the original value inside the iterator. Yeah, okay, now if I try to print this, it will give me the element in the order minus 5, 1 and 22. Let's see. Yeah, so I get the element in the ascending order. Okay, now this is how we print the element. Let's say now I want to, itr points to this first element minus 5, right? First element in this set. Let's say I want to erase the third element. Okay, so what I'll do is it plus plus. Okay, itr is the, okay, itr, can I do plus equals to 2? Yeah, I cannot do this, so I'll increment it once. Okay, then I again increment it once. Okay, and now I erase it. Okay, s dot erase itr. Okay, if I try to erase itr now, so what happens is it erases 22. Okay, 22. Now let's try to print the set again. Okay, for auto iterator. Okay, it equals to itr. Okay, itr. So in this case, now itr points to end, right? So I'll have to create another pointer which represents the front. Okay, so set int again, I'll have to create a pointer, right? New pointer, iterator it1 equals to s dot begin, which would point to the first element, right? So now use this pointer here. So it1. Okay, it does not equals to s dot end. Okay, IT plus plus. Okay, yeah. So cout star IT. Okay, to dereference this. Yeah. So now let's try to print it. Let's see what we get as the output. So we get minus 5 1. Okay, 22 gets removed because I have erased it. Okay, here. So yeah, this is how we work with the set. Okay, to check whether a stack is empty or not, we can use s.empty function. So if I try to print s.empty, this will give me a boolean whether this is empty or not. So since it is not empty, it will give me 0. Yeah, so I get 0 here. So this is how we work with sets. Okay, now let's talk about maps. Okay, so let's talk about maps. Okay, maps in C++. Okay, so a map is a data structure which stores the data in the form of key and value pair. Okay, so there will be a key which points to a value. Okay, you have seen this type of data in many places. Let's suppose we talk about the school attendance sheet. Okay, so there is a roll number which is associated to a particular person, let's say the name. Okay, so this kind of data is stored in the form of maps. Okay, now let's talk about attendance sheet. Okay, let's talk about this example only. Okay, so let's say my roll number in the class is 19, so 19 is associated with my name. Okay, Priyansh. Let's say 20 is my friend's roll number and his name is John. Okay, so this is how the attendance sheet looks like. So when ma'am calls 20, we'll have to say present ma'am or present sir, whatever. So this is how the data is stored in the maps. Okay, we have a key which is our roll number here, and we have a value which is our name here. Okay, so let's how do we work with map now? Okay, how do we initialize map? So we'll create map, then we will write the data type of key. So the data type of key here is integer, so we'll give int, and the key is associated to and then the data type of the value. So value is in the form of a string, so string. Okay, and then we create a map. We give it a name, so you can name it map as well, but I won't name it map. Okay, so I would give it name mp. Okay, so this is how we create a map. Okay, to work with map, we have to include map. Okay, at the top of the C++ program, we have to include its library. So has include map, we write at the top, and this is the syntax. Okay, this whole thing is the syntax of how we initialize or how we declare map. Okay, how we define map. Okay, so now to insert some values inside the map, we can insert likewise. Okay, name of the map, then the key. Okay, let's say the key is 1, let's say my roll number is 1. Okay, equals to the value. Okay, let's say I give it my name only, and since it is a string, it is enclosed within double quotes, remember this. Okay, and then semicolon. So at key 1, my value is stored. So if I try to print mp1, okay, it will give my name as the output. Okay, so this is how maps look like. Okay, now there is one more function to check whether some key is present or not. Okay, so if you want to check whether 1 as a key is present in the map or not, so we can use mp dot count, then the key which we want to search. Let's say we want to search whether 1 is present or not. So this will give us boolean. Okay, 0 if it is not present and 1 if it is present. Okay, so this is how the maps work. Okay, now if we want to print the elements of the map, what we are going to do, let's add a new page. Okay, let's suppose we have 3 id. So 1 is associated to my name. Okay, then we have 2 which is associated to some other name, let's say John. Okay, let's say third is associated to Thomas. Okay, let's say fourth is associated to Tom. Okay, yeah, so we have this many data in the map. Okay, now to print, we can use the auto keyword, right? For auto, x belongs to, now x is here a pair. Okay, so all these elements will be stored as a pair, right? As a key value pair, right? So x belongs to map name was MP in my case. So to print the key, we'll use x dot first. Okay, yeah, so x dot first represents the key, whereas x dot second represents the value in each case. Okay, first x will represent this particular thing. Okay, so to print 1 we'll write x dot first, and to print to print this string we'll write x dot second. Then in the second case, x represents this whole thing, this pair. So to print first value we'll write x dot first, to print the second value we'll write x dot second. Now let's see how it works. Okay, let's create another program, map.cpp. Okay, let's write the boilerplate code. Okay, yeah. So yeah, so let's include map. Okay, include map. Okay, now let's see. Let's say we created a map of type integer to string. Okay, attendance sheet I call it. I can name it anything, right? Attendance underscore sheet. Okay, yeah. So now let's say I try to uh, put some elements inside it. Attendance underscore sheet. Let's say my roll number is 1. Okay, so I assign it value now. Okay, yeah. Same way, let's say there are some more elements. 2. Let's say, okay, let's say this is John. Okay, let's try to change these values first. So let's say this is Thomas. Okay, yeah, Thomas. Let's say this is Tom, and let's say this is uh, let's call it hero, superhero. Okay, let's call it superhero. Yeah, so superhero might be the name of some person, right? So 3, 4, and let's say 5. Okay. Now there are only 5 students in the class. Okay, now if I want to print all the elements, all the keys and the values. Okay, so for auto, x belongs to map. Okay, map is attendance sheet. Okay, yeah, so see out x dot first to print the key. Okay, then I'll leave a space. Okay, within this space I can put this as well. Okay, this will mark. Okay, this will mark as the pointer. So x dot second to print the value. Okay, yeah, so now I'll put the endle. Okay, now let's see how is the output. So 1 points to Priyansh, 2 points to John, 3 points to Thomas, 4 points to Tom, and 5 points to superhero. Yeah, this is how the output is getting printed. Now if I want to know whether a key 6 exists in the map or not, so what I'll do, I'll try to print cout. I'll use count function. Okay, attendance sheet dot count. Okay, let's say 6. I want to check whether key 6 is present or not. So let's see what is the output. So it gives output as 0. So 6 is not present, right? So let's check for 5. 5 is present, so it must give 1. Yeah, so we got 1 as output. So this is how we work with maps. Okay, now we already got to know about how we work with sets and maps. So now we have final container, which is unordered containers. Okay, unordered containers. Okay, so let me tell you the difference only. Okay, we won't get much deeper into it. Okay, so it has unordered map, unordered set. Okay, unordered map. Okay, and unordered multiset and unordered multimap. Okay, unordered multiset and unordered multimap. Unordered multimap. Okay, now what is the difference between a set and an unordered set? Unordered we call it because there is no order. In the normal set the elements are stored in the ascending order, right? The elements were stored in the ascending order. But in the unordered set, the elements are stored in the random fashion. Okay, neither they are stored in the fashion they are pushed inside the set, nor they are stored in the ascending or descending order. They are stored in a random order. Okay, any element can be first, any element can be last. Similarly, in the case of unordered map, the keys in the ordered map are stored in the ascending fashion. So 1, then 2, then 3, then 4, then 5, irrespective of the value. The elements are sorted in the form of keys in a map, okay, normal map. But in the unordered map, any key can be first. Okay, 5, then 3, then 1, then 4, then 2. Okay, so this could be the order: 5, 3, 1, 4, 2. Okay, so there is no particular order of storing the keys in the map. Then that particular map is called unordered map. This unordered map is also called hash map. Okay, hash map. It has a huge, you know, it has a very important role when we talk about problem solving. This unordered map or hash map is used a lot. Okay, when I say a lot, that means a lot. Okay, so it is used at various places. Okay, when we work with the problem solving. So yeah, this was the only difference between the set and the unordered set, and this was the only difference between the map and the unordered map. So if you want to know them more deeply, so you can, you know, check the definitions, or you can check how they work in the documentation. Again, I'll recommend that you must, you know, look for documentations rather than watching multiple YouTube videos. Okay, you can watch, you can read from GFG's documentation. You can use W3 schools. Okay, so these are some, they provide some good documentations, okay, on the topics. So yeah, this is all for this lecture. Hope to see you in the next lecture.